Thank you. Thank you very much. I hope it sounds okay? Yeah? Cool. Thank you. Welcome to this session to Overpowered Kubernetes. It's an honor to me for being from this hometown, from Malaga. I hope you enjoy my hometown. Does it feel good? Yeah. Good. That's it. Thank you very much. Feel really proud to be here. First of all, you're not selling your soul by just staying here and listening to me, to Oracle, or to anybody, okay? It's just simple statement that, as we change our development cycles in Oracle, so there is new features coming every month, every couple of months to our cloud services, our technology, databases, and so forth, okay? So do not worry, this is just we may be talking about features that may come maybe in a future release or whatever, but do not worry. You can feel free to ask whatever you think. Okay? So that's it. And a little bit about myself. Well, I was told, they already told you that I'm from here, from Malaga. I started in Malaga, in fact, and I worked for Oracle for the past 5 years. And I started as an intern, and then I keep growing in Oracle from a technology perspective as well, not only from an experience perspective. But it's a really nice, interesting company, and I'm really proud of for the people who have here in Malaga. Okay, it's not only foreigners that were able to join the big tech companies. So most of you already know Oracle, probably. You may know Oracle from maybe the database, which is the most known product that the company had. You may know us as well from some Java experience, okay, from some acquisition, lots of daters, maybe not so funny, okay, which made some people to make lots of money, and maybe get another item, who knows. This is the stuff you know about Oracle right now, nowadays. What I want you to know through this session as well, I want you to change a little bit your mind, because we do more stuff than this, okay? We're not only this. We do some cool stuff as well, which is open source. We get focused on the community, and so forth, okay? We are actively participating in containers, conferences. We're supporting the community. We're putting engineering resources as well for Kubernetes, containers, and so forth. Okay. We also open source interesting tools for container-related stuff. Some of our projects, like serverless, like the FN project. I don't know if many of you attended yesterday the LONIC session about serverless in Java. It's a framework that is being open sourced by Oracle, and the engineering teams belong to Oracle. Okay. We have also NoSQL technology that is also open sourced, which is kind of interesting as well, which not only huge corporations but also small companies are using right now, nowadays. And also JavaScript frameworks as well, in order to help developers in the experience of developing web applications as well. Okay? So remember, do not only focus that we're just working on enterprise customers, but we also open source and we're giving back stuff to the community as well. Okay? So, my session today will be composed by specifically 4 points. As in the title says, it's about Kubernetes as well, but you may think, well, Oracle doing Kubernetes, what the hell is this? So, as this is a session which is intended to everybody, I will go through the basics about containers, how do we arrive to containers, and then what is the different approach we're trying to make developer people interested in try out the Kubernetes in Oracle. Okay? So, how many of you heard about containers before joining to the session? Most of the people, this is good. How many people have experience with Kubernetes before? Some of you, which is good as well. Okay? So, I'm trying to cover the pretty basic stuff for those who don't know anything about containers, Docker, Kubernetes, and then we go farther into the session. And why we do believe that we can overpower Kubernetes. Okay? So, from long time back during the development history of IT companies and so forth, the deployment, development process, the architectures, and the packaging, the infrastructure that's underneath. That's, we've been evolving in such sense from a waterfall. How many people from here developed sometime in a waterfall mode? So let's say you're already experienced developers. That was a long time ago. Okay. So we used to develop our applications into we called now a big chunk of monolith. We put everything on different places, maybe different VMs, but everything was running like in a whole package, and that was deployed somewhere. Maybe in some kind of physical server, and that server was deployed in a data center, the host is there, and we just run it and run our business application there. Then later on, we came to an agile model. How we arrived to this specific point? Well, because we needed to make some changes to the code. We were changing business requirements, and we need to make perform those changes faster and in an easier way and in a more secure way. Okay. So we developed a new development process. We split our application into several layers, and then we deployed into virtual servers instead of physical servers in order to do a better manage of the resources we were deploying to. And then those machines, that infrastructure, could be maybe a hoster, it could be also located in another place. Okay? Nowadays, maybe these buzzwords are more trendy today. Okay? We change again based on the agile model as well into a DevOps model. Okay? We've moved from an N-tier monolith application to a microservice architecture. We have all the components split and distributed into different places with different providers, or even deployed into the cloud, maybe on-premise. Okay, but it's highly focused on cloud as well. And then we package our application into containers. Okay, and those containers will be deployed most probably in a cloud provider. Okay. So, for those who don't know what containers are a new way to package and deploy applications. Okay, so if we have a look back at the previous way of doing this, we may have our infrastructure. Okay, then we have our hypervisor layer when we split the resources into virtual machines, and those virtual machines may have different operating systems, different libraries, different binaries, and that's how we make the usage of the resources of the infrastructure we have. But managing a VM, sometimes from a development perspective, could be kind of heavy. So those VMs could be like hundreds of gigabytes. Moving VMs from one side to another, maybe from development to production, was a pain because it takes time, lots of error, no automation at all. So could be a little bit more or less painful. Okay. Then, in order to solve this problem, or at least to relieve it, we go for containers. So we could think about containers as another way of virtualization, but instead of deploying virtual machines, you deploy containers. Those containers include all the binaries, all the libraries, and everything needed to run that application. And then you pack that in a file, and then you deploy that to the Docker engine. Okay? Containers could be different technologies, but it's true that the most well-known in the market is nowadays Docker. How many of you know Docker? Most of it. Good. So, but how did we arrive here to containers? I mentioned some of the points before. Maybe managing VMs was not so easy or not so grateful in order to make some changes to the VM because we needed to change the infrastructure underneath, or maybe to do some whatever kind of task. So, in order to deliver those changes, and even for the applications as well, it happens many times that when you deploy your application, it works locally. This works in a test environment. But when you move to production, then it starts crashing everything. Does that ring the bell? So, and then it starts the finger pointing. It's your code because you're a bad coder, you're a bad programmer. Now it's your machines because you screwed it up in the system administration. So, in order to avoid this finger pointing, the same container that you may be running into a development environment will be exactly the same that you will be running into production. And you make sure, because of the container, it has everything that is necessary to run. And it's more manageable because it's easier, and it's also lighter in terms of space and resources that it needs to handle. Okay? Then we are in a whole globalized world where whatever small company, even if they are small, maybe a couple of people in the company, they can make business with the whole world outside. Okay? So if we start a business right now, our potential market is the whole world that has access to the internet. Okay? So if we want to reach global scalability, we need to change the approach of the architecture of the application we're developing, or the systems we're developing. Okay? So containers are really interesting to be developing a microservices approach, where we split our containers that can be independent, those components could be independently scaled and can be independently deployed. So whatever change that I do, maybe to a component of my application, doesn't affect the rest of the systems. You remember the concept of isolation that Juan just mentioned a couple of sessions ago. Okay. And which is also more interesting from a business perspective as well for companies, which is it allows multi-cloud vendor. It avoids vendor blocking. So if you have your containers and you have your applications in a containerized world, you can deploy those applications to whenever Docker or Kubernetes or whatever container technology we're using are able to run. So if we're running our containers, maybe our systems in AWS, maybe for whatever reason they make prices higher, we can move our systems to another provider that also offers Docker or Kubernetes without changing most of the code. We may change some specific stuff, okay, if you're using maybe another platform as a service, service itself, or whatever, but the compatibility between systems will be way faster and easier. Okay. And so we mentioned about Docker, but there are several tools around Docker in order to make it, more for production purposes, we could say. Okay. These are some of the figures related to Kubernetes itself. Kubernetes is a tool that it's, we could say, in an upper layer than Docker, okay, in order to orchestrate several containers at the same time. Okay? So if we can run clusters of containers in Docker itself with Docker Swarm, okay? But when your system is growing, and that could happen really easily if we try to reach that global scalability, handle those containers or those clusters will take more efforts, more efforts. So we may be interested into here what tools can we use in order to manage those containers, those clusters. Okay? Kubernetes is one of them. It was developed by Google first, and then given back to the community, the Cloud Native Computing Foundation, some years back. Okay? So some interesting figures about Kubernetes, as mentioned before. These numbers may not mean anything for you right now, but 2,000 plus contributors on GitHub, so which means that this has strong support from the open community. Okay, it's an open source project and has a strong support. Okay. Then, from the surveys that is delivering to companies as well, they mentioned that 71% of the people or the companies that were using containerization, they were using Kubernetes itself. There are some others, Docker Swarm, Mesos, and some other technologies, but 71% of the surveys are using Kubernetes, which makes it way interesting. Okay? And from those 71%, 84% of them they were using it for production. Okay? There you go. For production purposes. So I will cover a little bit of the basics of Kubernetes. Okay? I don't plan to maybe start running commands and so forth, but at least to have a clear understanding what is the Kubernetes architecture, okay, for your information, and then maybe jump into we'll go deeper into the overpowerment that Oracle can deliver to Kubernetes. Good. So first of all, in Kubernetes, your application will be defined in a YAML file. Okay, so if your application or your system is composed by maybe different applications and so forth, you define all of them in a specific file. Okay, what are the networking rules? What are the ports that your application is listening to? What is the image of the application that it's using? If it's an NGINX or if it's a Tomcat application, or if it's a whatever kind of component, you define it in this YAML file. Okay? You set the number of replicas if you want for that component, if you want it in a clusterized way, and so forth. Then that YAML file it's given to the Kubernetes master, okay, the Kubernetes architecture from a runtime perspective. It's quite straightforward, quite simple. You have a master that contains all the schedulers, contains all the metadata about the workers, and so on. Then you deploy that to the master, and the master it takes into account the file, understands the state of your system, how many replicas, and includes everything that you deployed, you read it down in the file, and then it deploys it to the worker nodes. Okay? Those worker nodes will have basically or mainly two specific pieces. It will have the kubelet, which is the specific agent that is in constant communication with the master, and you have then the Docker runtime engine, which actually executes the code, the runtime part. Okay? So, then after that, inside the nodes, the worker nodes, you may have different pods, which is a set of services, a set of applications, visual components at the end of the day, okay? With a set of IPs, the volumes, in order to, if we're running a database or we're running, we want to maintain state, what are the storage pieces that those nodes or those pods have access to, okay? And then we can put also some labels in order to manage metadata, maybe to split the resources in a more fancy way, okay? And then the service, which exposes the application to a specific port, specific IP, and it can also load balance between the different containers on the different nodes. This is really interesting because in case that any node fails and your container is down, but you set to the master that there will be several replicas of it, the master will understand that there is a node fail, and it will automatically deploy those components into another worker node, which makes it more interesting for production purposes, fault tolerance, and also high availability. Okay? So, I want to talk right now about the container native. This is something which is specifically mainly developed by Oracle, okay? We want to address some of the challenges. Of course, Kubernetes and containerization, we solved or we relieved some of the problems with containerization, but there are still some challenges, so we solve problems to create different ones, as you mentioned also before. So, first of all, what's the maintenance? Okay, most of the surveys, based on the previous numbers, found really interesting to solve management problems, because we mentioned this is a new technology that we need to learn. We saw the master node that has some components to maintain. What happens if this fails, or what happens if the master fails? Okay. Then we need to figure out also networking, storage rules. It should just work. I just want to focus as a developer to, with my code, maybe doing a better gathering of requirements, or maybe executing my algorithm in a proper way, optimizing it, okay? But not just figuring out how storage and networking should work. Okay. Then managing the teams as well. So how can if the development team is way big enough, or it grows enough, we may be interested into splitting resources. I don't want the networking guys to have a look at where maybe my code is, or where can I access a specific application, or maybe if it's a microservices way, I don't want this team that develops specific microservice to have access to the whole environment, just only to the pieces they have. Okay. And then also how to implement the continuous integration and the continuous development. This was something that was relieved as well, or maybe solved in the previous, we could say, in past stages. Okay, we just push our code and it starts all the pipelines and so forth. But that was for web applications or for tiered applications. Okay, but if we work in a containers world, the approach is similar, but the technology itself is different. So the tools we need to use may be different as well. Okay, so these are some of the points that are interesting to us. So for these specific purposes, Oracle developed several services. Okay, they develop a specific managed Kubernetes engine. Okay, so I, as a developer, should just work on my containers in my application. I manage, I define the YAML file, and I deploy. And the master will be handled, and I will just don't care about that. It's just work. Okay. Then there is also a registry. I haven't mentioned this before, but every time you want to deploy or to define a new application, you should generate an image of it. Because from that image, you can generate an amount of containers, whatever amount of containers you may want. Okay. So that registry should be also in a proper way. If you want to handle by yourself, you need to maintain a server and you need to maintain specific components for make the images available for be deployed later into the runtimes. Okay. So we offer services that stores all the images, offers to the users in an optimized way in terms of latency, because the image is quite big, and also in a highly available way. So you may have your applications always available ready to be deployed. Okay. Then the continuous integration piece, which I show you later on in a demo. Okay. In order to implement the continuous integration and continuous delivery of your microservice application, and then the FN project for serverless, which was referring to the previous session, or session yesterday from Kubernetes. Okay. So, from a management aspect, you may see these three specific pieces. Okay. If you go to the right side, starting from the right side, you will see that customers or users, at the end of the users, will have access to the worker nodes. Okay, maybe they have to do some whatever kind of customization, or they may have access to the machines and to the resources. Okay, but we'll offer an automated way to create all the nodes, all the clusters, everything by maybe a REST call, a REST API call, or just through a user interface in a really easy way. So I don't need to be a Kubernetes master, or I need to do any kind of training or huge deep dive in order to have my application running or to create my cluster, which saves time as well and saves errors that could happen during the provisioning time. Okay. Then all the metadata and the important pieces to make the cluster works will be managed in this case by the provider. Okay. So it will be highly available to different availability domains, to different zones where the master could be deployed. And also we'll offer the default dashboards for Kubernetes to manage maybe in a more friendly way through the user interface. Okay. And then there will be the registry next to of course, the runtime environment to make the applications to be deployed in a faster way, in a more secure way. Okay. So now many of you may have heard about, I heard about this service in AWS. I may have heard about this service in Google Cloud. So why as a developer should be interested in running this in a different provider? Okay, what's the overpowered piece that appears in the title? Okay, I will focus, as a developer, I would be interested in running Kubernetes in this specific platform because of two specific points. Okay. First of all, the continuous integration platform, the automation that we deliver with Wercker, which I will show later on a little bit, and then the quality of the infrastructure or the resources that are provided for Kubernetes. Okay, you may have, we'll go later into details. Okay. So, in terms of Wercker, how many of you have heard about Wercker? Not too many. Oh, some guy over there. Okay. So, Wercker is a container native platform which allows developer teams or the development teams to implement the continuous integration and continuous delivery workflow in a really fancy manner and a really easy way. All the integrations that need to be done to maybe deploy to the running Kubernetes cluster or to managing the teams to split the resources, that's going to be handled by completely the platform. Okay. We can also create different workflows, which could be interesting over to run some tests, or if I want to deploy first to a test environment or to development environment to a Q&A environment, we can go, we can split the resources in a really fancy way. I'll show you this one. Okay. So in order to make your application, your system to work with Wercker, the heart of the Wercker system is the Wercker YAML file. Okay. In this YAML file, you'll see there are some specific, weird words. Let's go a little bit deeper into that. We will define steps. A step is a piece of several steps. If I want to maybe push my code into the registry in order to generate a container later on, I'm maybe interested in to run it, follow all the commands that I need to do in order to build that image, or to build that, to perform or to execute that specific step. Okay? Maybe a step could be deploying to a Kubernetes or to deploy to a production environment, or could be to deploy into a test environment, could be maybe to run some tests, or maybe tests for about the UI, or whatever kind of step we want to perform. Okay? So it's the commands. We also can parameterize in order to make it available for our own environment. Then, apart from those steps, there will be also pipelines, which is a set of steps. Okay? So maybe in order to deploy to a Kubernetes cluster, I need to do several steps. I need to first maybe compile some code, I need to expose some service, I need to allow some networking rules. Okay? So I define those in this step, and I patch them in a specific pipeline. Okay. Then every pipeline will be deployed, or I can use them. A set of pipelines can be deployed into a workflow, and that workflow will define all my continuous integration, my continuous delivery in a graphical way, which we will see later in the UI during the demo. Okay. So this specific service and this technology will allow the following. The developer can just focus on the code, maybe make some changes to the code, can commit the code, the change, and then push it to a specific place. We can push to a GitHub, or maybe to our internal Git repository. Okay. Then it will trigger a Wercker. It will trigger Wercker. Well, Wercker will be hearing about the changes that we do to the repository, development that do to the repository, and then we'll start all the building process. Okay? The building process will start the workflows in Wercker, and we'll start following the different steps on the pipelines that we defined previously as our continuous integration, continuous delivery flow. Okay? Then we can push those images generated to a specific registry, and at the very end of the step could be just the final deployment to production. Okay? So if we focus later on into once it's running into production, I mentioned before that there were two specific points. First, the automation based on Wercker, and then the infrastructure resources that are very interesting from a developer perspective. Why is this? You may have heard in other cloud providers or in the cloud world that there is the famous problem of the noisy neighbor. So what that means, well, every cloud provider, cloud is based on highly hyper-virtualized environments, so I can rent resources, but you may be sharing resources from other customers and from other users. Okay? So if I'm running my production workload, my production system, where all my users have access to, and then I have the colleague who I'm sharing hardware, and is running maybe a big data workload or a machine learning workload which consumes lots of CPU, my production performance, well, it could have an impact in my production. Okay? We try to relieve that problem, which is well known into the cloud community, by almost delivering a hard partition into the resources underneath. Okay? So you may see in other places that you may rent maybe half core or weird shapes. Okay? But we will deliver almost a hard partition underneath. So we make sure that the resources that are assigned to every user are focused on the user. So if my colleague or the user that I'm sharing resources, or I'm sharing hardware, if they're running huge amount of compute resources, I'm not getting my production impacted by that. Okay? Then, in terms of networking, if I want to reach that global scalability that I mentioned before, I may be interested in to deploy into several regions. Maybe those regions need to be, those applications that are deployed into different places need to be talking to each other. So I would like to those components to speak as fast as possible. Okay. So the networking that is delivered by the platform or the infrastructure underneath, it's low latency one, which can also reach peaks of 25 gigs per second in terms of bandwidth. Okay, and I can deploy that with just the power of a click. Okay, so we'll see later on. And then, from a storage perspective, these are some of the numbers that are public in the documentation. So if my application that I will be running into Kubernetes, it's a highly I/O application, input-out application, it will be supported by these numbers. It's even, Oracle feels very proud of the performance that it could have, that it can also deliver an SLA related to performance. So in case your application is performing lower than the numbers that are published, you may be eligible for an SLA, which is also interesting. Not from the cost perspective, but from a relaxed perspective. So as a developer, I would be interested in running this in a really highly available and performing infrastructure, because I can avoid my users, the users that are using the systems I develop, to be calling me and complaining about how slow the system is, and just complaining about the performance of the system, of the application they're using. Does that make sense? Okay. So, apart from the complaining about the performance of the system, you shouldn't forget about the first piece, which is the automation into the development cycle, to make development easier, faster, and at least to make the developer experience way better. So automation, okay? We can focus the time that instead of maybe doing some troubleshooting, doing whatever kind of other stuff that has no business value, we can start focus that time or investing that time in more interesting tasks. Maybe doing a better requirement work, or requirement gatherings, or whatever other tasks that may be interesting. Okay? So, now I'm going to jump to a demo. I'm gonna fingers crossed, the gods of the demo gods, and that's it. Let me show you a little bit the platform. Okay. Let me duplicate the screen. Okay. So you see this is our main dashboard. Okay, in order to access the service, nothing special, nothing new from here. Let me access. Because we went out of. So, as I mentioned before, in order to make the development experience way smoother and better at the end of the day, I may not be a Kubernetes master in terms of, I don't know how to deploy, if I want to deploy it on premise, or if I have to build it by myself. I may be interested in doing so, but if it's automated, why not using it? I can save tons of time doing so, and also avoid errors as well. Okay? So, this is the containers screen, right? If I want to create a cluster, a highly available cluster that is deployed, the worker nodes are deployed into different data centers for high availability purposes and for fault tolerant purposes. If I want to do that, I just need to click on Create Cluster. Okay, I will select a name, Kubernetes cluster, for instance. Then I can select a version. These are the current versions we have right now. Can you see it properly? It's a little bit fuzzy, right? So, let me. Okay. Better now? Okay. So we can select then a version. Okay. The more versions Kubernetes will be releasing, we'll be including them into the console. Then we select a virtual cloud network. So where are the networking resources that may be interesting to run? And then we select the load balancer subnets. This is really funny because by default you need to offer a couple of load balancer places in order to make the platform understand where they need to put them. So you have 2 load balancers for high availability purposes. Okay. Then we select some, well, we enter some data related to the internal IPs we want for our worker nodes and also for the masters, and then we can later on node pools. Okay, we'll go deeper into that. Once we enter this information, and after some minutes, around 10 minutes or even less, we can see our cluster created. Okay, this cluster shows some information about the version of Kubernetes and so forth, and then we select the node pools. These are the worker nodes, and as you can see, one of every worker node is deployed in a different subnet, and it's evenly deployed into a different availability domain, which is a completely data center connected everything by this low latency network I mentioned before. Okay, so I can have the applications I deployed into Kubernetes in a highly available mode, and also connected through quite interesting Windows updates. Go away. not now. Okay. So that's it. This is the way you just create a cluster. Okay. So quite simple, quite straightforward. I don't need to be, a real understanding person of Kubernetes in order to have my cluster up and ready. Okay. And then we have Wercker. Okay. This is the pipeline, or at least the service of the technology, which allows the continuous integration and continuous delivery of the system that we're developing for Kubernetes and containers. And if we go for pipelines, we'll have here just a quick application. Okay, it's application deployed or developed in Angular. Okay, and these are the different deployments I've been doing. Okay, as you can see, it doesn't always work. I'm not a master Kubernetes neither. Okay, but at least there are some fails, and you get notified by the fails if something in the steps fail. Okay. So if I want to define my continuous integration workflow, as I mentioned before, I just click here on workflows, and this is the workflow I defined for my application. Okay, I want this to perform first a build, then to perform some specific tests for this application, then I want to push the application or the images to the repository, and then the final step, deploy to the Kubernetes engine. Okay. I define all of this in the specific Wercker file, as we mentioned before. This is the virtual machine I was using for development. Let me enter here. Okay, it's a little bit small. Better now. Okay. So if we have a look at the Wercker file, you can see what I mentioned before. Okay. These are the different steps and the different pipelines in order to build the workflow I just showed you before. We can add maybe later some tests and some other deployments to a Kubernetes environment or whatever need that you may have for your development lifecycle. Okay, we just add it here, and Wercker will understand the steps you want to perform. Okay, so for instance, let's change something. Let's change something just in order to build the trigger. Okay. For instance, this was just to change a little bit in the code to perform to execute the trigger. Okay. Right first. Love you, Bing. Okay. Now, as previously in the Wercker, I just I just connected GitHub because this is going to get pushed to GitHub. I have Wercker connected to GitHub, okay, but it can connect also to Bitbucket if you have private repositories, GitHub repositories, or some other ones. Okay, so if I perform a change and I just add it. Add the Wercker file, change page, and then we push the code. Okay. These are my credentials, and then it's getting pushed. Okay, so now we go to the Wercker. And we go to the main dashboard, go to the application dashboard. Then you will see that everything started. Okay, so all the steps I defined into the Wercker YAML file will start to get executed by the workflow we defined. Okay, we can see from just a single pane of glass all the steps, how are they being executed, and if we go and if we enter the step, or at least the pipeline that is going to be executed, we can see the different output as well. Okay, this is generating all the images. And it's generating everything necessary in real time. Okay. So now it's pushing to the repository, and you can see this in a real time. Looks cool, right? What do you think? Okay. So this is a sample application. You will see later on. That it's maybe just an example. It's an Angular application that you just enter some data from a user and gives you a score about maybe because we're given a loan or we're given something. So it's like a risk score. Okay. So this takes some time. You can also abort in the meantime if you want it. Okay. And from a management perspective, as we mentioned before, I can have several people to have access to the workflows, to the different steps, and whatever. Okay. I can also set environment variables. This is the Kubernetes master that we will deploy in the application, the Kubernetes engine, the usernames, the repo. We will be pushing the code later on, and so on. Okay, we can define that in the proper place. It's executing the push. Okay, and now we'll be finally deploying to Kubernetes engine. It's executing the push. You can see that properly, right? A bit bigger as well, if you want. Okay. So, how many of you are using similar tools like this in your continuous development or continuous integration for containers, for those who were using Kubernetes before? Were you using Jenkins or, for instance? That's it. Okay. But in those environments, you may be interested into maybe to do some specific manual tasks and you create everything by default. This way, you have already everything set up. You just enter your credentials, set the environment, and then just start working with it and deploy it. Okay. Okay, so let's have a look how the run is going, and it's already deployed. Okay, so into the deployment pipeline, at the very end, I added a step which is to get the load balancer AP in order to access my application. There you are. Okay, so if I take this IP and I access it, I know it is in the port 3000 because I defined that in my application. Okay, and I access it. Unless we blocked the port 3000, which is probably happening, right? This is very fun. Okay, but the application should be there. Okay, sorry for not checking the ports beforehand. But the application is there. In fact, it was an ugly application, so I feel happy that it doesn't appear there. Okay, but the application will be finally deployed. Application is ugly as hell, so it better not shows up. Okay, that's why I'm a developer and not a designer. Okay, so maybe you can show it from here. No, just a second. This is IP, right? Now let me show it. I'm finishing. Okay. Remove this. Because here I have access from outside. And there you are. That's the application. Okay. As you can see, it's ugly as hell, but that's the application that we just deployed. Okay. To Wercker. And the center. Okay. And we can make this bigger in order to wow. But you trust this is the IP we just deployed from Wercker. Okay. So, just to wrap up, okay, and then we finish the presentation with this. You know, containers. We'll talk about the benefits of containers. You know, allow avoids vendor locking. You can deploy to multiple providers, and you make, you know, the production steps, well, the development steps to go to production way easier with Kubernetes and Docker. Then remember, we can automate and make the development experience way better with Wercker. Okay, we can make automated things and spend time or invest time in do more valuable things, more valuable tasks, and then we shouldn't be worried about the performance that our application could be delivering to end users because of the resources and the infrastructure we mentioned before. Okay, that was all. I'm open for questions. Thank you very much. I hope you enjoyed.